Okay, today we're going to be continuing with section 4.5, part 1, and this is going to be solving exponential equations. So an exponential equation is one in which the variable occurs in the exponent. We've been talking about these exponential functions. Now we're going to solve these as equations. So here I have a comparison between a polynomial, which would be x to the third. We would take like a cube root to get x by itself, but here the x is in the exponent, so it's an exponential equation. When it's an exponential equation, we have to use logarithms in order to be able to solve that. Okay, so I have a couple here I'm going to start with. The first technique that we're going to look at with solving exponential equations is when they have like bases. So this doesn't happen all that often, but if you happen to have a case where you have like bases, then what we can do is just work with the exponents. So I'm going to have 2x equals x plus 1, and I'll just solve this little linear equation here. Subtract x from both sides. So I'm going to have x equals 1 as my answer. So pretty simple there, x equals 1. So if I happen to have one here, again, these are like bases, so I'm going to set the exponents equal to each other. And then I'm just going to solve that. So maybe it's going to be easier to subtract 2x in this case. So I have 3x equals, I'll subtract the 6. So 3x equals negative 9, divide by 3. And so x is going to be negative 3 as my answer there. Okay, so most of our equations are going to be those that have unlike bases. So when you can't either have like bases or make them into like bases, then we're going to have to follow some guidelines that I've outlined here for being able to solve an equation that has the x in the exponent. So when your variable's in the exponent, you're going to need to follow these directions here. The first step is that we're going to isolate the exponential expression on one side of the equation. So this is my exponential function here. So I need to isolate that, which means I'm going to need to get rid of the 8 and the 4 first. So the first thing I'm going to do is get rid of the 8. And so I'm going to subtract 8 from both sides. And so I'll combine the 36 and the 8 together and get 28. Then I'm left here. Here's my exponential function. So I need to get rid of the 4. So I'm going to divide that away. So I'll divide both sides by 4. So I come down to having e to the 3x equals 7. Okay, from here we know that logarithms and exponential functions are inverses of each other. So when we compose the two together, they're going to cancel each other out. So we're going to actually take, in this case, the natural log because we want our bases to match up. Remember, the natural log has an understood base of e. So we need those to match up. So we're going to take the natural log of both sides. That's going to let these cancel and leave us with just a 3x. Here we're going to have natural log of 7. And this is just one number. So this is going to stay together. It's not going to break apart. We'll divide by 3 and we'll get this as our answer. So if it says an exact answer in WebAssign, then it is wanting this format here. Okay, if it says give a decimal approximation to 3 decimal places, then you need to put this in your calculator and get the decimal approximation for that. Okay, so here's another one. This one we're asked to find both the exact and the approximation. So on this one, we've got 3 to the x plus 2 equals 7. Well, we do not have like bases, so I'm going to have to try to get this by itself. And we're going to do that by taking the log of both sides. So if I take the log, okay, so we take the log of both sides, and now we can apply the properties of logs that we know, and that is that we can take our exponent and bring it down in front. So I'm going to bring it down. I'm going to put parentheses around it so it stays all grouped together. Right now I need to get x by itself. So the first thing I'm going to do is I'm going to divide this log of 3. So I have x plus 2 equals log of 7 divided by the log of 3. So again, if I'm trying to get x by itself, what I'm going to do is I'm going to subtract this 2. So I'm going to have log of 7 divided by the log of 3, and then I'm going to subtract 2 from that. This 2 does not get combined with the 7 and the 3. It's completely separate. Another way, if you remember our change of base formula that we could write this, would be the log base 3 of 7. So these would be equivalent to each other. And then if you want to get a decimal approximation for that, then you would just put that in your calculator and round it to the appropriate number of decimal places. And that would give you your answer. So your answer would be negative 0.228756. One thing I wanted to mention is you may have seen, if you've done logs before, you may have seen another technique, and that is if I have a base of 3, then I actually take a log with base 3 of both sides. This is not as common of an approach, but it does work. So that what we're doing there is we want these bases to match up. So if they match up by the properties we've learned, all that goes away and you're left with x plus 2. Then subtract 2 from both sides, and that's going to give you our answer there. So it's an alternative way to do the problem. Okay, so we have another one here that we want to practice with. This one we want to get the e by itself. At any point, if you feel comfortable with these, I would suggest pausing them, trying them, and seeing how you do with the work. But here we want to get this part by itself, which means we need to get rid of the 8. So we're going to divide both sides by 8. So we'll have 20 over 8, which is 2.5. Or you could put 5 halves, whichever you prefer. So we want to get rid of this e so that we can bring the x down. So we're going to take the natural log of both sides. I apologize for the pen. Okay. All right, so we know that ln and e are going to cancel, and we'll have 2x equals ln of 2 minus 5. Then we're going to divide by 2 to get the x by itself. So we have ln of 2.5 divided by 2, and so this would be our exact answer. So approximations we get from the calculator as a decimal. Exact answers are going to have ln's and logs and exponentials and all these different things left in them. Okay, here's one I would suggest you to try. Okay, if we look at this one, we don't have anything that we can add or subtract to get rid of this. We can't divide anything away, so we're pretty much ready to go ahead and take the natural log of both sides. And again, I chose natural log because I have a base of e in my exponential function here. Okay, so those are going to cancel. And then it's just a matter of getting x by itself. So the first thing we're going to do is subtract 3. Be very careful that we do not combine the 4 and the 3 together. We have this and then subtract 3 from that. We'll divide by negative 2. So x is going to be the natural log of 4 minus 3 divided by negative 2. Or alternatively, with your signs, you would have negative ln of 4 plus 3 divided by 2. Okay, the next one here is definitely a little bit more complicated, but it is something you need to know how to do. And this one has exponentials in 2 places, so we can't really isolate those. What we're going to have to do is we're going to have to try factoring this. And so in order to factor it, I want us to do a substitution. So the substitution that I want us to do is I want to let y equal e to the x. Okay, so I'm going to rewrite this. So what I'm going to have is this is going to be y to the second, because if I have e to the x and that is squared, then that's going to be e to the 2x. So this is going to be equivalent to y squared. This will be minus y, and this is going to be minus 6. Okay, so what I want us to do with this quadratic is to factor it like we would normally factor. So we want to know what multiplies to give us 6 and subtracts to give us the 1. So that's going to be a minus 3 and a plus 2. So when we solve this, we're going to get y equals 3 and y equals negative 2. Okay, at this point, we want to substitute back. Okay, so we know that y is e to the x, so I'm going to replace my y with e to the x. And then to solve this, we know that we take the natural log of both sides. And when I do that, those cancel. So we get ln of 3 over here. Okay, so we take the ln of both sides. This would be x. Here we have a little bit of a problem. If you put ln of -2 in your calculator, you're going to get an error. So when we get that error, what it's telling us is that we have a domain restriction. We can't take any log of a negative number, so we get no solution for this part of our equation. So we only have one answer, and that answer is over here, and that's that ln of 3. Okay, especially if you're going on into calculus, it's really important that you can handle these exponential functions and all their different ways that you might see them. And so this is one way you might see it here. So this would be equal to 0. Sorry, I left that off. So what we want to do is we want to take out our greatest common factor. So in taking out our greatest common factor, that's going to be an x and an e to the x. So we have an x in both and we have an e to the x. So in this first one, it's going to leave me with a 3. And then in the next one, it's going to leave me with an x. Okay, and so from here, we want to solve this. And we'll solve it by setting each factor equal to 0. So we have to be careful. We have 3 different factors. This is a factor, this is a factor, and this is a factor. So we're going to set each one equal to 0. So x equals 0, of course, is just that's an answer there. Here we need to actually solve for x, which means we'll take the natural log of both sides. We can't take the natural log of 0. We can only take the log of positive numbers, so we get no solution for this part. And then this is going to be -3. So our answers here are going to be 0 and -3. Okay, here are 9 different problems for you to practice with that have a combination of different techniques using exponential functions. So my recommendation would be that you pause this video and that you try all 9, and then you watch the video and check your answers. Okay, on this one, we have like bases, so we're just going to be able to set our bases equal to each other. Okay, so I'm going to add 2x to both sides. And I'm going to add 5 to both sides. So I'm just going to solve this, and I'm going to have 6/5 as my answer. Okay, here's another one where we have like bases. So I have x squared minus 1 equals 1 minus x squared. We have a quadratic here, but I'm still going to get my x's together and my constants together. So if I add an x squared to both sides, then I'm going to get 2x squared. If I add 1, I'm going to have 2x equals 2. Divide by 2. So x squared is 1. If I take the square root of both sides, then I'm going to have x is plus or minus 1 as my answer there. Okay, next one. This one, we've got to isolate this exponential here, which means I need to get rid of the 2 by dividing it away. So e to the 12x equals 9. We'll take the natural log of both sides. Okay, these will cancel conveniently for us. Then I want to divide the 12 away. So x is going to be the natural log of 9 divided by 12. Okay, looking at the next one, this is my exponential function that I want to isolate. So the first thing I'm going to do is subtract 8 from both sides. Now I have it isolated, so I need to cancel this e by doing the natural log. Okay, so now that I have my x down on level ground and not up as an exponent, then I'm ready to just do regular algebra to get rid of the x. So the first thing I'm going to do is subtract 1. So I'll have negative 4x. Again, sorry about the pen today. So negative 4x equals ln of 12 minus 1. Don't combine together here. Divide by negative 4. So x is going to be the natural log of 12 minus 1 divided by negative 4. Okay, here's one that we need to factor in order to solve. So this is one that we're going to let y equal e to the x, and we're going to rewrite this. So we're going to rewrite it as y squared minus 3y plus 2. So this is a quadratic that's factorable. So we're going to have y minus 2 and y minus 1. I'll set each factor equal to 0 and solve. Okay, so now I'm ready to make my substitution. So in the place of y, I'm going to go back and put e to the x. So e to the x equals 2 and e to the x equals 1. So we still don't have x by itself, so we're going to keep going a little further here, and we'll take the natural log of both sides. So I'm going to have the natural log of e to the x equals the natural log of 2. So that gives me x equals the natural log of 2. The other one here, I'm going to have e to the x equals 1. So I'll do the natural log of e to the x equals the natural log of 1. So we know that the natural log of 1 is 0. So we end up with the natural log of 2 as one of our answers and x equals 0 as the other answer for us. Okay, here's one that we have a base of 2. It's an exponential function, so we need to get rid of the 3 first of all in order to get this part isolated. So we have 2 to the x equals 8. I'm going to take the log of both sides in order to get this x to come down. So by our properties, we can bring this x down in front. Okay, so when I bring the x down in front, I'm going to have x times the log of 2 equals the log of 8. And then I'm going to divide by the log of 2. So x is going to be the log of 8 over the log of 2. And if you remember from our change of base formula, that would be log base 2 of 8. Okay, on this one, we already have our exponential isolated, so very much like the one we just finished. We'll go ahead and take the log of both sides. I'm going to bring that x down in front. Divide by the log of 3. And so x is going to be the log of 14 divided by the log of 3, which is equivalent to the log base 3 of 14. You do not have to go and rewrite it like this, but you do need to be able to get it to this point. I will be looking at work on these problems when it comes test time, so be sure that you understand how to show me the steps of your work. I know some lost points on the last test because of not showing your work, and that will happen again on this test, so be sure you understand how to show the work. Okay, next one here, we want to again get this exponential by itself. So I'm going to divide by 5. So e to the 6x minus 1 equals 5. This time I'm going to take the ln of both sides, the natural log, simply because I have a base of e, and we know that natural log and e cancel each other. Okay, so we're going to get x by itself by first adding 1. Again, don't combine these two together. They don't need to be combined together. Divide by 6. And so x is going to be the ln of 5 plus 1 over 6. Okay, last one on our practice here. We've got to get this by itself, this exponential. So we're going to divide by 7. So we get 4. We're going to take the log of both sides. Okay, this lets this come down in front. So we're going to have 2x times the log of 3 equals the log of 4. Okay, and then we want to get rid of both the 2 and the log of 3 so that we're just left with an x. And we can actually do that in one step here. Okay, so the 2's would cancel and our log 3's would cancel. We'll just have x equals the log of 4 divided by 2 times the log of 3. And that would be our answer on that one. One thing I wanted to show and I talked a little bit about an alternative way to do this. If we were going to do this the alternative way, and again, I'm mainly showing it in case you happen to have seen it this way before and liked doing it that way, we'll still divide by the 7. So we'll have 3 to the 2x equals 4. Because this has a base of 3, I'm going to take log base 3 of both sides. Okay, by their properties, all of that cancels, and we're left with 2x equals log base 3 of 4. Divide by 2. And so x is going to be log base 3 of 4 divided by 2. Okay, so this method works and is equivalent to this. This is probably the more traditional way of doing these problems. It's probably the way you would see more in calculus if you do plan to go into calculus. I'm just kind of showing you alternative ways with this. Okay, so if you want like all the steps written out for these, here's a couple slides that have those. You're welcome to just freeze the slides and video and write down any notes that you need to on these.